Okay, so today, by the end of the hour, you should be able to tell me about the graph's end behavior. You probably don't even know what the heck that is, all based on the equation that it has. You'll probably, hopefully, be able to tell me about the intervals where a graph increases or decreases. So basically, that's just the part where it's going up or down as you read from left to right. And then the next part is local absolute minimums and maximums. Those are the big three things you got to learn for today. And they're pretty easy. So let's talk about the degree and the name that goes with that degree. If you have an equation that's like, you learned about those in algebra, and those are simple equations. They're also known as linear equations. And what degree do they have? Degree 1. Because the little power right here on this term is a 1. There's a 1 right there, so that's degree 1. This part of it right here is degree 0. But you always pick the bigger of the degrees and say that for the whole thing. So this is degree 1, this is degree 0. It's like there's a little x to the 0 there, because remember x to the 0 means 1, and 3 times 1 would be 3, so it makes sense. But you don't ever write that there. But that shows you that it's degree 0. That's degree 1. So what if it was like this? Y equals 2x to the third plus 7. What degree would that be? Degree 3. Okay. Now degree 2, we kind of skipped over that. That was like these things. You have a name for those. That has a degree 1, that has degree 0, that has degree 2. The overall is degree 2, also known as something that starts with a Q. Quadratics. All right, good. So we've got quadratics. What are they called when they have a 3 like this? Cubics. Very good. And anybody remember the next kind? Quartics. Very good. All right, moving on. What is a polynomial? These are polynomials. They are bunches of terms connected with pluses and minuses, and each little term has its own degree. All right, that's degree 3, that's degree 1, that's degree 2. What wins? Degree 3, so that's a third degree polynomial. That's degree what? 1. What happens when you have a fractional degree? Then it's not a polynomial at all. It doesn't qualify to be in the polynomial club. Kicked out. And what if it's a fraction that has an x in the bottom? Can anybody tell me that degree of that polynomial? Yes? Yep. Yep. X to the negative 1, for instance. That puts the x down in the denominator. And also can't be in the polynomial club. Can't have negative exponents, can't have fraction exponents. So both these kind are bad. So that actually doesn't have a degree of negative 1 because it's not a polynomial. So only polynomials can have degrees. All right, so basically, they might throw in a trick question on you at some point and ask what the degree of the polynomial is. And you would be able to say, oh, wait, it's got a fractional exponent. It is not a polynomial at all. All right, moving on. So this one's degree would be what? 2. I just looked at that for, and it's also known as a quadratic, right? All right. What's the degree of the blue one there? Yay. Degree of this one? Uh-huh. This one? And I really should have had a trick one in here, but this is kind of a trick one because the 8's in the middle, and normally you lead with it. And I just want to make sure kids don't think that the first one is always the highest one. It should be, if you write it right, but this should have been put over in front, and therefore then it would be a more logical 8 for an answer. But the answer is still 8. So whatever's the biggest, that's the degree. Okay, end behavior. This can get confusing if you say increasing or decreasing. This part right here is actually increasing because you always read from left to right. Okay, but if you look at it from the perspective of where is this going, it's going down. If I go farther this way, if I go farther out this way on the left side, it's going to keep going down. So should I say increasing or down? They kind of like seem opposites. What you say is up or down. We keep it simple on these. The left side of this thing is going down. It is not where it's going. You really should just say, where is it? It is down. And the right side of this is up. Okay, so that's a down, up. What's this one? Up, up. Just where are the ends? Where are the ends of the graph? Okay, how about the next one? Down, down. How about this one? Up, down. Okay. This last one, last two. Down, up, and down, down. Okay. So I can tell you which way any equation will go. Okay? So give me a crazy equation. Somebody just give me a crazy equation. Okay? X to the fifth plus 4x squared plus 83. All right, I can tell you which way it's going to go. I know that that one is going to be going up on the right and down on the left. And if you want to check it by graphing that, well, I'm going to calculator. Everybody grab your graphing calculators. Going to need them for today's homework anyway. I know. Well, that's easy. That's an easy one. Nope. Well, you can do a different one in a minute, but all right. So, x to the fifth plus 4x squared plus 83. That one goes down on the left and up on the right. Anybody verify it by looking at the graph? You can always zoom out. If you zoom out far enough, you'll eventually be able to see where it kind of heads. All right. So, want to give me another one? Oh, if it's a straight line, then that just means that you're either zoomed out too far or in too far. But how about this? Do you agree that on the right-hand side it's going up? A pretty much straight up and down line, even if it's straight up and down, almost straight up and down, it's down on the left and up on the right. All right, so give me another one. I can do this. Y equals x to the 107th. Yep. All right. I can tell you that that one also is up on the right and down on the left. You're catching on. Odd and even does have something to do with it. The degree of it tells me something. It doesn't tell me the whole answer. Let's go back to some that you know off the top of your head. If I said this, you'd be able to say it was what? Up, up. You know what that looks like, right? It was like this. So that's up, up. So how do you get that? Because it's degree 2. Does that automatically make it up, up? No, because what if I did this? Then what would it be? Down, down. But what it does tell you, the degree, if it's even, means that both sides will be the same. Yes, they'll either be both up or both down. So if I said x to the 4th, it would act the same exact way. If I said y equals x to the 4th, I know that's up, up. Sorry, 4th. Because it's even. They both have to either be going up or down. How did I decide if they were going to be up or down? I said up, up. Could have been down, down. Why isn't it? Yes? Yep. You got the two things. Now, I'm not sure you said it right, but let me just make sure. Here's the two things. You said the negative in front tells you something, right? And the degree tells you something. You've got it nailed down to the two things. Now, what I want to know is, just judging by ones you already know, like this, what does that negative in front tell you? That it's flipped. But what about the up-down part? Okay, but what I'm asking is it telling you the left side or the right side? Because they happen to both be going down or both be going up, then it's the same, so it won't matter. But what if it's like this? Then is the sign in front telling me the right side or the left side? Do you remember what x cubed looks like? Remember how it looks like this? So what if I threw a negative in front of it? Then it would look like this. No, it's not. It's telling you the right side. Okay, so the sign in front of it tells you the right side. And the degree tells you whether they both go the same way or they both go opposite ways. You know what I'm saying? If I know the right side just from looking at this, I know the right side automatically. If it's negative, the right side's down. If it's positive, the right side's up. So here's the notes I would take if I were you. Negative 2x squared plus 3x minus 6. The sign here tells you right side is down. Now, if there had been a positive there, then the right side would be up. All right. This tells me whether what? Exactly. This tells me if it's even. Here, I'll go like this. If even both ends go same way. If odd, they go opposite ways. All right, that's one of the most important things that you need to learn for today and for this rest of this chapter. You already had the hardest part of the test, but they'll have more tests. This will be on it. Pretty much guaranteed it. So if I were you, I'd put a star next to this part because that's important enough. Okay, so tells you the right side is down because it's negative. If it had been positive, the right side would be up. It does not tell you anything about the left side. This then tells you if both the sides go the same way or if they go the opposite way. So now I'll give you a crazy one. Is this up, up, down, down, or down, up? Don't say it, write it. The left side is the first word you write, and the right side is the second word. And if I were you, I would, let's say I thought it was down, up, I would always do the right side first. Do this one first, and then that tells you the other one. So Mr. R says up, down, and that means you said, you decided this first, down. And how did you decide that? Because the negative, and you're absolutely right. That's all you got to do. Tells you the right side. And then I look at this, and it told you what? That they're opposites. So if this one's down, that one has to be up. Okay. Next step. Is this down, 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 up, down, or up, up? Sneaky. All right. What do you think? Which side should I start with, right or left? And what do you say on the right? You say the right side's down. And B, are you doing that based on this negative in front? Oh, interesting. What you should have done is notice that this is actually the number that's supposed to be written first, and therefore it really should be this way. If I rewrite it like this, now, do you agree with yourself? No. Okay. So if this side is not down because it's not negative, it's positive. So it's up on the right. Do you get that? Because this was the key term that told us the degree. That was the lead coefficient, and that was the sign that mattered. Okay, so it's up on the right-hand side. On the left-hand side, maybe this minus makes it look like it's negative. It's not. The right side's up. The left side is what now? Down. Because it has to be opposites, because it's an odd degree. All right, one more. Because the left side and the right side always start on the right side. Down or up on the right. And the right side's up. And on the left side, down, because it has to be going in opposite directions, because it's odd. Raise your hand if you think you get that now. Okay, good. That's how you do the second thing we were supposed to teach you here, which was, that's end behavior. That was the first thing. Okay. The second thing is about increasing and decreasing. So let me jump into there's a bunch of practice on that. There we go. Okay. Let's get into the increasing, decreasing part. Would you agree that the graph is increasing in that little zone right there? Because as you read from left to right, it's going up. Obviously, in the other parts of the graph, it's decreasing. How do I say the intervals over which it is increasing? I would write it like this. You just put them in parentheses and say it's increasing from this to this. Well, the question is, if this is 3, 0, and this is 1, -4, should I say 1 to 3 or should I say -4 to 0? It's increasing as you go from left to right, so those are the numbers you need. That number and that number, which are x numbers. So you'd say it's increasing from 1 to 3. You get how I use the x on them? I didn't use the -4 and I didn't use the 0. Those are the y's. Okay, so it's increasing from 1 to 3. So, if I was talking about this part right here, if it goes forever, I say it's decreasing from where to where? 3 to infinity. It's not how far down it goes, it's that it's going that forever this way. From here, forever that way, it will be going down. So from 3 to infinity. End behavior. Just learned that a second ago. Left side, right side. What should I always start with? Right side. In this case, it probably wouldn't matter because I can see it's up and then down. Left side's up, right side's down. Question? I recommend parentheses because if I'm talking about where it's decreasing, at that exact moment at the 3, does it look like it's decreasing? It's not actually decreasing there. It's decreasing after the 3. That's why we don't include the 3. If I did this, I would be saying that it is decreasing at 3. It's not. It's decreasing after 3. So I use parentheses. Okay? All right. I know some of you got into thinking that parentheses are for the infinity because you can never get there, but any other number always has brackets. It's not really true. This number has brackets if it is actually doing what you want at that moment. And it's not decreasing at 3, so I don't put a bracket. All right, next up is local minimums and maximums. To understand this, it is helpful to think of something else, like, for instance, strength. Who in here is probably, would you nominate to maybe be able to beat me in arm wrestling? Peter. All right, so Peter's our local strongman. Okay, good. So, if he is, and we'll test that later if you want. I got some pipes too. All right. If he can beat all of you guys, he's the local maximum. Okay. And what if he can beat everybody in the whole world? Then he's the absolute maximum. I'm guessing probably not likely. Okay. But for a kid his age, doubting it. But anyway, if you go local minimum or local maximum, you can be the local maximum and the absolute maximum at the same time. It's like locally you're the smartest kid, and worldwide you're the smartest kid. That's possible. It's not likely. All right. So on this graph, this is a local maximum. Is it the highest of all? No. Around its neighborhood, it's the highest spot, but it's not the highest spot of all. So that is a local maximum right there. What do you think that spot's called? Local minimum. It's a low spot. Is it the lowest of all the spots on the graph? No. So it's not the absolute minimum. The absolute maximum, there's none in this graph because it goes up forever. You have to assume there's arrows on each end, I wish there were. I'll put them on there now. And the absolute, wait a minute, where is it? Absolute maximum is the highest, wait a minute, this one, there we go. Getting confused with all my arrows. Absolute maximum, there is none, because it goes up forever too. It goes up forever and down forever. So there's no minimum and no maximum. Extreme values are like embarrass Minnesota. You know what they've got credit for? Coldest temperature in Minnesota ever recorded was embarrass Minnesota. International Falls is always up there, and there's another one too. It's really, really cold. It might be. Would you agree that if it's got a title like that, it's kind of an extreme? It's on the low end. I'd rather be the extreme on the high end, although that's uncomfortable too. You know where that is? Hottest place ever? Death Valley, yep. Death Valley in Nevada. Super low spot, super hot. Do you know that generally speaking, it gets colder as you get higher? As if you think about that, if you go up in a plane, I don't know if you've ever noticed this, there's like ice on the windows as you're flying along up there thousands of feet up. Okay, it's because it's so cold. There is actually a formula that tells you the higher you go, the colder it gets. So of course, on the top of mountains, it's usually pretty cold. In Hawaii, there's actually mountains that have snow on them. In Hawaii, which is obviously nice and hot and lush and warm, but the tops of mountains are so cold, not just because there's snow up there. Why is there snow up there? Because it's so cold. Uh-huh. Cool, cool. Which island has that on it? Do you remember? The Big Island? Okay, cool. I definitely want to do that. The kid was talking about starting at the top of a mountain on Hawaii and biking down it. It gets really cold on top and nice and warm at the bottom. All right, so extreme values are anything that's extreme. Like, look at that. Doesn't that look extreme to you? It's the lowest spot locally. Now, it doesn't mean it has to be the lowest ever. That's kind of extreme. And this is kind of extreme, as in going down forever. But you can't name it. It goes down forever, so you can't call it an extreme value. So it's basically the extreme values are the minimums, the local minimums and maximums are the extreme values. And the last thing are the roots. Remember the roots? Don't forget those. The roots are where it touches there and there. Those are the roots. Okay? So, let's see if you've learned anything here. The end behavior on this one. What's the left side? Up, right side? Down. This spot right here is called a local maximum. That spot right there. And yes, this is also a 0. And what's that other spot right there? That's also a 0 or a root. Roots and zeros and x-intercepts and solutions are the same thing. All right. In this case, this is an x-intercept and it's the y-intercept. It's getting kind of confusing, right? But it's touching the y-axis right there. All right. If it touches the y-axis at 0, that means if I looked at the graph of it, it'd probably be something like this. And I have to say minus 0 or just leave it off. Because there's nothing at the end here to be a y-intercept. Well, that means there's a plus 0 at the end. That means the y-intercept is 0. All right. I'm going to give you an equation, or I'll give you a graph, and you say possibly the right equation or not. You can stop me right now, can't you? Is that possibly the right equation or not? No, there's like 2 reasons it's not possible. What would it be? What is that telling me? Right side's down, but in this case, right side's up. So wouldn't you agree I have to lead with a positive number? Okay, now could it be right? Why not? Because they're going opposite directions. So therefore, it'd have to be like degree 3 or 5 or 7. Okay? And then, how about if I say plus 3? Now all of a sudden, is this possibly the right answer? Can you prove, without graphing it on your calculator, can you prove it's not right? Yes, what do you think? This last number I just put in, what did that tell me? The y-intercept is positive 3. Isn't that possibly right? Ah, okay. Okay, so you're going based on what you know about a cubic. You know a cubic kind of looks like this, right? And then this plus 3 means the whole thing should be shifted up. And you're right. And we're going to get into more advanced stuff about reading the roots, but I should have picked something like this. Now, you don't know what that parent one looks like, right? So now, if I ask you, could this be is there anything that you could prove that that's not the right answer? There is something if you think about it. Yes? Y-intercept has to be something positive, right? And there's nothing here. So I'd have to add in like a +6 or something at the end. Now, could it be right? Yeah, because it's positive in front, which means it's going up here. It's got an odd degree, which means it's going in opposite directions. So could it be right or not? That could be right now that I've added it and this +6 in it. All right, good enough. Local maximums and minimums. Again, local min, local max. They're not the absolute maxes and mins, though, because it goes higher in other spots and lower in other spots. All right. Now on this one, this is the part where you can prove to me that you really understand this stuff. I'm going to ask different people for different things. Increasing. Start right here in the front row. Tell me a spot where it's increasing. From right there? I agree. Now, counting this out, that's at -5 in case it's hard to read from where you're sitting. How would I say it's increasing from -5 to -3.2? See, it says it right there. Notice I used the x numbers of it. Where is another spot that it is increasing? Yes? From 0 to infinity. Very good. Infinity should be touching. There we go. So from there to there. Decreasing the other spots. It's good enough. Okay. Yep, question? Is it increasing at 0? No. That's why we use a parenthesis there. Good question. All right. Next up, end behavior. Up, down, down. What is it? Just look at the ends. Where's that? Where's that? Up. Okay. Up. That was awful. I'm going to try again. Up. Okay. Local maximum. Find me a local maximum. Yep. That spot. Right there. Local max. What? Oh, I put it on minimum. Sorry. I said maximum, but let me move that down. There. And now it's not circling the right spot. That's okay. Local minimum. Is there more than one? And hopefully you can see them. They're here and here. They're points. So you'd put what comma would be -5, 0, and 0, -50. Absolute maximum. Is there an absolute maximum? No. There is sometimes, but there isn't on this one. How about a absolute minimum? There is an absolute minimum. The lowest spot of all is right there. It'd be 0, -50. All right. Extreme values. Anything I circled. This, and these I circled, but you can't really tell me where they are, so you don't list them. You don't list negative and positive infinity. Otherwise, you'd always list them in extreme values because they're, well, anyway. The bottom line is don't list infinities in your extreme values. And the last one is the roots. They're here, and there, and there. Those are the roots. Okay. I think we've covered it. So you got some work time. And here is your packet. Average person has 1,460 dreams per year. Wow. I had a good nightmare last night. There was a crazy guy that was on the loose, and we had this camp where all these people were sleeping overnight. It was sounds like one of those slasher movies. And there was this one person. We were trying to decide whether or not to tell her that there was a crazy person on the loose because we knew she was really the nervous type and she probably wouldn't sleep all night. And so, but then again, I had decided we got to tell her because what if she wakes up in the middle of the night and she goes out to the bathroom, this crazy guy loose, and she doesn't even know it, and so then she never comes back. And anyway, And then it ended up with somebody chasing me on an ATV in the snow, and I don't even know what that means. So I think I can stop recording.